Okay, hello everyone. This is Postgres TV, hacking Postgres with Andrei. Today, hi Andrei.
Yeah.
So we continue to work on WAL compression, but before that, first of all, we don't have Kirk today. Unfortunately, he couldn't join. It's a pity because we wanted to congratulate him with successful commit of recent patch related to PSQL functionality when we want we say echo hidden, right? Or you can show it. Great.
Yeah, let me show his patch. It's probably visible on GitHub now.
Mm-hmm.
Thanks to Nathan Bossert, who committed it 16 hours ago. So this is the first patch authored by Kirk. Oh, congratulations to him.
Like a solo author in this case, like of course you helped, but only like with pieces of advice, right?
I've done a very small review, yes.
Okay. Yeah, that's great. Congratulations, Kirk. I hope you will join next time. So great. Let's see how other patches will be committed as well,
Yep.
right? I hope.
Let's continue hacking.
Right, great. And I think it's obvious optimization, because if you see some SQL, you want probably to grab it and use in your code. Like if, for example, if you develop your own client for Postgres or something. So it's good that now we can just copy paste and so the idea is that before SQL was not ready to be used in these comments, right? But now it is. It is ready to be used. So quite obvious optimization, beneficial for all users. And as a reminder, maybe someone don't know who is watching us. It's a great feature of PSQL, quite old one. You can say echo hidden. It's there in the comment, and PSQL will start printing all SQL queries it uses to operate. So you can see what is behind \d, for example, and so on, which is great. I like it and sometimes use. Good.
Yeah.
So
another note. Yeah.
Go ahead.
Okay. Another thing that I wanted to talk about a little is that we in previous streams we were discussing compile time of Meson build and regular auto tools build. And I was looking through the internet if someone who has already benchmarked that stuff, and
Peter Eisentraut
did. Yes.
Can you just, for me, probably maybe everyone knows, but just for me, briefly explain what Meson is? Like, I know it's like kind of build system, but what's like how is it different from others?
And another cool thing about Peter Eisentraut's blog that there is a clear explanations why it matters. I just let's remember here.
Yeah,
supply chains. Like pictures that we all know, and the brief explanations that Postgres depends on auto tools, which is not maintained actively right now.
Mm-hmm.
And to mitigate risks of unsupported builds, we, like a community, decided to switch to Meson because it is very actively maintained for now.
Okay, but why? Like, is it somehow better than?
Yes, some community members claim that it's faster, and I heard many times that like it just saves you, just gives you productivity, saves you time. And Peter benchmarked Meson on almost every possible compiler, and here is a lot of useful stuff. And where is not this post? Meson review. So here is the benchmark.
This I didn't see. Mm-hmm.
Yes. So Peter benchmarked it on different operating systems, And like Meson setup is slightly faster than other tools setup on both platforms, but compile time is essentially the same. Like here is this single-threaded compilation. It's 2 minutes for other tools and 2.5 for Meson. And for compiling with many threads, where is it? Here, total compilation of Postgres is 27 seconds for other tools and 27 seconds for Meson. So exactly the same time on a development machine. Yeah. That's quite interesting because like many community members was expecting that Meson is faster. Well,
Right,
it,
like
it
almost
is,
2 times faster, right? But
yes, it saves you 4 seconds during configuration, in fact.
no,
And well,
well,
this, yes.
it's 4 seconds. It's relative here because, well, it's of course this is some MacBook obviously or some Mac. So many people use it, but still, like on different machines, it can be absolute value can be different, right? We should talk
I
about
don't
it.
think, I think it's
Really?
very stable across
Okay,
MacBooks right now.
unexpected to me. Okay, so
Compilation time is almost exactly same on for some reason on here Peter benchmarked it with 4 CPUs on machine and got 2 times slower compilation if Peter would pick a bigger machine. It would have this no matter the power of machine, if it's bigger than 8, it's not increasing with more CPUs. So you have this 27 seconds on MacBook Air, you have this 27 seconds on MacBook Pro, you have this 27 seconds on server, you have this 20 seconds on anything. And anything that is capable of multi-threaded build. That's kind of...
So the conclusion is
universal invariant of Postgres compilation.
Okay.
27
well,
seconds.
You compile Postgres, I think, 1,000 times more often than I. So of course you know it much better. So
it's some stream we should fix it. Maybe you will compile on your machine too and hack something.
I do it. I have source code and I do it, but I just somehow prefer.
I compile 3 or 4 times a day. So
okay, I compile probably
not
a few times per month, maybe, right? When I check something, so much less frequently. But I always do it. I prefer using. I have it on my MacBook, but I prefer doing it remotely because I just don't want my machines to slow down, and I have too many tabs in my Chrome opened, which already a challenge. And if I also compile and if I have a call with someone, it's like, no, I just offload this task to some remote machine. Remember last time we had an issue. So
yeah, that's
you remember, of course.
Like when you're live streaming from the same machine that is compiling and running tests, like it's kind of risky. And I do the same today, by the way.
Okay. But for scalability issues, we offload some tasks, like vertical split of functionality. You move this work to some different machine. So bottom line of these posts is that performance improvement is not so as expected.
Yeah, it's maintained. Meson is expected to be better maintained.
This is main reason to migrate.
Yes,
maintenance.
And bottom line for me personally is that I'm still with auto tools. It's just the tools that I know. I feel lazy to learn about Meson, but learning is a good thing. But you can learn all the stuff. You have to choose something.
Okay, makes sense.
I will stick for a year or 2 with other tools.
It looks, for me, it looks like the same as this idea. Let's move away from Docker and Kubernetes like consider Docker deprecated and so on. And but many people, including myself, still use Docker because it's just a habit and it's easier and so on. Like, and you think I should move, but still use it. Right? So it's similar, I think.
Yeah, and another thing that I want to tell is that Peter's blog is brilliant. Like every post is worth reading, and I was looking for like for benchmarks of a compilation of his method and found like a lot of very interesting stuff. For example, measuring new features by create commands. Like here, how many new stuff you could create in a skill in Postgres grammar each year with different release. And we see that starting from Postgres 11, we do not add new create commands. And there is a lot more of stuff. I'm not going to spoil. There is an interesting thing below, but we are here for hacking. If you have some spare time, read
yeah,
this
also
blog.
not hacking related, worth mentioning, Peter also is participating in SQL standard committee now, and also blogging sometimes about the progress of standard development, SQL standard development. So it's very interesting to read those posts as well.
And I think all that stuff is like extension to standard, like non-standard, in fact. And seems like we stopped doing new stuff.
Yeah, what's happening? It doesn't look good. This particular create analysis doesn't look good. Like so many years without progress.
We don't need to extend grammar. We can make our
I'm
database
joking.
better.
Well, when I was like third grade at university, I remember we needed to study standard. It was part 2. It was like 1,300 pages or so, and it was so difficult. It's so overloaded with stuff. It's very like SQL is very probably like JavaScript. You have 1,000 ways to do the same thing in different ways, right? So it's extension should be maybe well thought and maybe in particular areas like it happened with JSON and now happened with graph extension for graph queries. How's it called? I don't remember. Some interesting name was chosen for this.
CipherSQL?
No. It was some I forgot already, but it was some three letters, some abbreviation for this part of graph-related parts of standard.
JavaScript grammar is very orthogonal. Means you need to learn small subset of features, embrace them, understand them, and that's it. You can do all the magic.
Same. You can just use like SQL 92 standard and do a lot of stuff. Not everything, of course, and maybe not in fast way. In the end of the day, standard doesn't care about indexes at all, right? It doesn't introduce such definition as index, so it doesn't care about performance. And if you don't care about performance, you can use like four clauses in your select statements, and that's it.
Yes, but from a developer point of view, Postgres grammar is 20,000 lines of code. It's just impossible to read. It's huge, and it's not auto-generated. It's human-written single file of 20,000 lines of code. I was looking here recently because we are working on a sharpening system as PKR, and we had a performance bottleneck in parsing by Go, and we decided that we want a small subset of grammar that can be parsed quickly.
Postgres grammar, right?
Postgres grammar, yes. Right. And if it's not parsed quickly, we fall back to using full grammar.
Okay.
And we looked in re-implementing this this Yak grammar, and it's immense. So the team just opened the file and looked at it and was scared and closed the file. So the grammar is just too big to understand, and it's impossible to refactor it.
I recalled how this new part of SQL standard is called, which is devoted to graph operations, graph-related work. It's called SQL/PGQ. That's why I was PGQ. Yes, it's called PGQ.
Like PGQ, it's
So,
something for queues, I think.
well, only few people think so. Like people who used Postgres long ago,
And
because
do you
PGQ
mean that
unfortunately is not very popular. I mean,
PG is not Postgres? PG is something else?
uh,
Like,
property graph queries.
uh-huh.
Okay, so I definitely noticed that this name is stolen by SQL Standard Committee, and like it's even more, like I always say like it's a pity that PGQ, I mean the tool PGQ is not so popular because it's like underused, I think, because its properties, it was developed very long ago by Skype, but its properties are very good, and this is the right way to work with queues in database. But
The
yeah,
thing is,
managed
it's not
Postgres
a problem
systems.
of PGQ. It's a problem that too many hackers are doing their own PGQ and doing it somehow wrong. Like
Well,
doing
not only
Q.
hackers, any backend engineer, as I
Yeah.
notice, at some point of their career, implements queue in database. So many attempts, but PGQ was the right attempt, done by Skype, and it's a pity that its popularity is low and it's like hidden knowledge, lost knowledge, I would say,
Well,
unfortunately. And now the
it's not
standard
perfect.
uses this name in different context. So, yeah.
Yeah,
Okay.
makes sense.
It happens. Okay,
Let's hack.
so yeah, we don't have a lot of time, and let's to be short,
Okay.
and as you said, as you wrote me earlier, you want another attempt to continue with
Yes,
compression of
yes,
walls,
yes.
but we are not sure that it will succeed, but we will try as usual, right?
We will try. We have 30 minutes to try.
Okay,
If I failed, I think that's nothing bad will
it's
happen.
okay, right?
So we stopped last time. Where? Let's see where we stopped. We changed B-tree sorting so that each record can contain many pages. We changed B-tree build so that it would be well logged by many pages at once, not by page, but 32 page and 32 page and again. So we made bigger records that are well logged. And today I want to go on. I've removed our login stuff to check that our things are passing top tests. I've run all top tests. I couldn't do it previously because my laptop overheated, but I did it this time because like hacking or video streaming
It's not compatible with Zoom streaming, right?
yes, on this machine. And now I want to compress all those pages together. I've done some homework. I found a function that is assembling one WAL record from many pages that are FPIs, two-page images. And now I want it to combine together and be compressed together. First, let's see what record assemblation is doing. It is iterating through blocks that must be all recorded as a single record. For every block, it is checking if it can be emitted, determining if the buffer need to be full logged. If so, it is doing cool stuff. It is checking if there is a zeros in the middle of a page, and if so, removing it from WAL logging. And then it is compressing each block and adding this block to so-called RDT datas. data. No. Here we want
Data
to
is
change.
already plural, so data sounds doesn't sound right. Okay, I'm like, okay.
Datas. The record data, and record datas. I know. Record datums. There's so much, so many words for like piece of bytes in databases because everything is piece of byte. But let's move on. So I want to start first with removing this whole stuff because it is because it's not good for a purpose of combination of all the stuff together. It's easier to combine many pages as whole pages than to combine shrinked pages together. Let's do. Where is it? So we are effectively disabling that whole computation. If we have some way of compression. Next thing, I want to remove compressed page buffer.
Why?
Here, this is buffer for a result of a compression of a page. Interesting that it is not of the size of a buffer; it's a size of a maximum production of Z standard and LZ4 and PG-LZ codecs. It's a maximum length of a block that can be a result of a compression. The thing is, compression usually it shrinks data, but in some cases it is extending data. And to be prepared to this, we must allocate enough room to accommodate all the stuff.
Okay.
Do you understand me?
I'm not sure. Like compression sometimes lead to bigger size. Like I don't understand this. Why is it so like
A result of
right?
compression might be bigger than the source.
Why?
For real data, usually compressed data is smaller.
Right.
But for most of inputs, result is slightly bigger.
Most of it, or just
in fact, most of. This is the tricky part. The thing is, there is no magic in compression, as you may know. Average, like you have all possible inputs of block size length. Average size will be slightly bigger than it was before compression.
Average size. Okay, I see.
Yes,
I see.
average size would be smaller, would be bigger, but most real sizes for data that you can actually find in nature will be smaller. So for noise, compression noise is always results in some extension of data length because noise is random and you cannot predict it. Compression codec is trying to predict next byte on the base of a previous byte.
Right.
And if it is predicting correctly, it is compressing data because frequent data inputs are smaller and rare data inputs are slightly bigger. That's why we accommodate here a little more than block size. In fact, it's I think it's 9 kilobytes or so.
Interesting.
That's interesting macros. Like it's maximum of PGLD max block size, and in fact, it's just 4 bytes plus input.
And you want to remove this buffer?
No, we have here a buffer for one compressed page, but I need a buffer for 32 compressed page. So I have to remove it from here. I will remove comment entirely because I don't have time to write it properly, and allocate a compressed pages here. And I have to allocate this memory now. I will allocate it along with this register buffer. Where is it allocated? Find it. I think it's here. Whenever we allocate space for registers buffers, we also allocate compressed pages too. Pages, and the size is I don't remember the size. I'll make it slightly smaller font. First. So now we have this chunk of bytes, which is ready to get a result of a compression of many pages. Let me see one more epoch. Oh, no, it's the same. I don't think that we need this memset stuff. Now we should use these registered buffers. And what we do here. We should avoid this call now. I will currently this call is doing compression of one block, and instead of compressing one block, we must copy this data to compress it later. What's going on? To compress it later, we should take this this page and copy it to some buffer where we concatenate non-compressed pages. So currently we have all the pages in different memory regions. We must build continuous.
So, sequential, they should be together, right?
So here we declared compressed pages and also not yet compressed pages. Not compressed. Or how to call it? Decompressed. It's not decompressed. Okay, not compressed pages. And also not compressed page size to know how many data is there.
It's not always 32, might be less, right? Fewer pages, or it's always 32. Like I forgot if you want to compress always 32 pages. But
no, we will have records of different size. And not 32, it might be 3 or 7 or something like that.
Right.
We should initialize this stuff. Not compression not compressed pages. And it can be of both sides. It can be smaller than yes. And also at some point we have to initialize it. Do we initialize it? I think at the beginning of assembling WAL record here. What did we call it? Not compressed page size 0. And where the place where we previously were compressing page, we are assembling not yet compressed. We are going to write not compressed pages plus not compressed page size. Destination source page. And how many bytes? I think block size. Here, we got that stuff. We copied everything to some buffer. And we shouldn't be using compressed pages anywhere now because we deleted it. I do not understand what is this RDT data is. It's a stack of pointers to pages. Do we need it or we can forget about it entirely? Where do we allocate new RDT data? First, we are just taking it from this. From register buffer. Okay, so if we use compression, if is compressed, we should just point it somewhere and say that it has 0 length.
But
No, it's a bad idea.
there's switch and I mean, okay.
Just don't know how to change it next.
How to change what?
Here is an array of
Right.
data chunks that will be later composed into a single chunk.
Mhm.
And I want to interfere into this. And I want to interfere into this. How to do that? I want to place all the data into first chunk. So this code is just too complex. Do it online.
Also lacks of comments, I think.
No, there is comments like on almost on every line, but it's
Right, but also I noticed like before, if you go up, we break actually, like you see break depending on no, it's just this is for none and it should not happen, right? But before you also break, so this code is not achieved for certain cases, right? So we have switch. Okay.
we should like go through all these RDT datas and replace all we can just do it. No, it like we have a buffer, we have an array of these registered buffers, and every registered buffer has this RDT data installed in the registered buffer, and they are also organized into linked list. So every registered buffer has this R datas, and every R data have also linked to next R data, because some R datas do not have just can be skipped. Let's do it that way that we can skip all them. Where do we link them? Here is it, that linkage that we we set pointer to next buffer and change the head of a stack to new value.
Maybe we should change the structure somehow, right?
I think we should just here do this link only for first FPI, and remember the pointer to data, and we will place a pointer of this RDT data to the place where we compressed all the pages.
Also, each page can have holes. So like it's
Yes, I've just removed this whole stuff for compression enabler stuff,
I see.
because the code is in mostly difficult because of these holes, because we have to do this surgery for every page. But I have switched it off for any WAL compression method besides none.
So in this case, we just don't care about them, but it's not super efficient, maybe, right? Or
I think zeros will be compressed well by any
right?
codec.
Okay. Well, okay. Makes sense. Maybe we should like, I mean, this is RDT, blah, blah, some like tracks where position, like our position of record. Maybe we should track all positions for all 32 records. No, like, or no, okay. I'm just okay. So I mean, we could have structure for 32 or up to 32, but okay, maybe it's.
I think that we should not update this RDT data at all if we are doing WAL compression, and update it when we are doing compression of this not yet compressed pages. I'm not sure if it sounds like.
But again, they can be located anywhere. I mean, they can.
No, we have composed
already.
them already. We made them pre-concatenated before doing compression. And I think we should do it. Like, yes, I think we should disable it the same way as it's done here. Debugging this stuff will be much harder.
Yeah, I think we need
we can start debugging before bugging.
We need debugger here, I think. What the debugger, like step by step to
Currently,
see.
I'm bugger, not yet debugger. And this piece of code, which is doing this RDT data, can be omitted too. And so we are removing this. No, we can't remove it. Okay, let's remove this part. That's the place where we are writing how exactly did we compress, which compression codec is used in WAL, and we have to write it anyway. So, and The thing is, now we are changing how WAL is written. And after changing how WAL is written, we have to update how WAL is read. And it will be even more difficult, actually.
Right, and also PG wall dump, we need to make it work as well with these.
I think PG wall dump can just, it's just keeping this kind of records. It's not interesting. It's just blocks.
Okay, so I mean it will work automatically if we
Yes, it just
reading part,
prints a number of pages that is looked, but it's not printing contents of these pages.
Good.
Oh, so I don't know what to do next. Actually, I think I need to retreat and try again.
It's okay, but just can you remind me, please, why 32? Why these numbers? Like it's 256 kilobytes, right? And
This is just a random constant.
right.
Let's find it in source code and see why it is. It's called XLR max block ID. Here is a comment.
Right.
It's 32 because it's taken from a, I know how to say it correctly. It's random number.
Okay, but so I mean,
arbitrary number.
We want more because we expect better compression and so on, right?
No, we don't. 32 is fine. We want to use.
I mean compared to one because
yes, definitely
more
we
data.
want more than one. Because
but you don't think a bigger number would be helpful than 32? I mean, maybe we should test it somehow a little bit using real data from walls. I don't know. Like
makes sense totally.
Also, CPU overhead. Of course, like to make decision, like compression versus CPU overhead, and then understand what's the best.
Look,
But
when
it's a whole research actually, right? So.
Yes, when you are what's the compression in nature? It's finding data that is resembling itself. So you're better compressing next bytes if they are resemblant to previous bytes.
Right.
So if you take 2 pages, second page is resemblant to first page.
Right.
So second one, so you have not very good compression for first page and better compression for second, for third, and so on. So I expect that most size of a resultant record is the size of a first page, but it won't be close to compressing 32 times.
Of course, yeah, I understand. So we right now Postgres compresses just one page and it's 8 kilobytes. And if, for example, we have a wide table, each record is quite big and probably occupies like a lot of inside this page, up to 2 kilobytes, right? Because it will be toasted otherwise, right? And then we compress. So if we have very wide table, we basically insert only 4 records into one page. 2 kilobytes, right? So 4, and it's not enough knowledge to compress well, because just very little. We don't know about the nature of. I mean, compression doesn't know about the nature of this data, and
I need to draw a chart somewhere, but I don't know where to do it.
On ceiling. Okay, I'm drawing. Okay, well, it's okay. I mean, I'm just trying to understand why 32, and maybe it's not the optimal. I always raise this question if I see some constant. Why is constant? Why not? Because it was probably defined long ago, where computers were smaller.
Yes, but compression algorithms were about the same in compression ratio. Yeah, actually, for our purposes, this constant is a result of compression ratio, and it must be like connected to compression ratio of the same magnitude. Why? Because if you have like too wide wall records, it's not good. You have to extend them for a reason. And it makes sense to put together as much pages as you get compression of like compression ratio, expected compression ratio.
So you mean if we want a better compression or paying some additional CPU cost, we probably should know should we have more pages? If we
No, it's not about CPU cost. It's about like consider that we want to extend this constant and say 33.
Okay.
Why should we do that? Because next page is compressed better than if we put it into next record.
I see. You mean compression ratio that additional like memory, increasing memory here will give us. Yes.
Let's say it's 1. If we use
as now, basically, right?
Yes. Not exactly, but
okay.
If we are saying 2, we get like I know, maybe some benefits.
20%.
Huge benefits that you like can be measured. If we say it's 4, we still get some more benefits. If we say it's 8, we get
already not that good.
Some diminishing benefits. Yes.
It's not linear. I understand that. It's not.
I think that the difference between 32 and 64 will
not
be
noticeable.
Not noticeable, and it's not noticeable like benefits, but instead we get a huge continuous wall record when you cannot insert more wall records in its state. So it's interfering with other workload on OLTP database.
Right. Also, well, memory overhead is not huge. When we increase this, and again, I'm curious about CPU. How compression will behave? Will we have bigger CPU utilization because of this change?
I don't think there will be any difference between 32 and 64 here.
No, I mean between 1 and 32, obviously there should be some difference. We should pay some price to deal with more.
But I think when we will implement this technology, we should try 16 and 64.
Exactly. This is I like we need benchmarks, but it's a whole again benchmarks is usually in the beginning.
I don't think that we can make it lower than 4.
Why?
Because
I mean we can. You mean it's not worth it?
No, it won't work. I know that there are records with 3. Currently, if we set this constant lower than 3, it will fail. It won't pass test because when we are wall logging bitary split, we will log parent, left child, and right child.
Interesting.
So we need 3 pages together.
That's interesting. Okay.
I think that it will pass with 3, but 4 is just around good number, better than 3. I heard that in some cases P is equal to 4.
Yeah, if we have current situation like single page compression, then 4, 16, 32 we already have 4 data points. I mean for future benchmark, and it's already interesting to look at, right? So, and benchmark is usually in the beginning you underestimate the amount of work you will need to finish it. Usually, sometimes order of magnitude you need more.
I think because with this technology I should implement it offline and we can benchmark it online because it's just too complex to hack it on air.
Let's do that. Yeah. Let's do that. Yeah. Yes, and just in case we can choose some smaller topic next time. We have a couple of ideas if you're still thinking about in this. But this is super interesting, and benchmarking is, well, I mean, compression is very interesting topic. Okay, I think we need to call today, I guess. At least we're out of time. It's okay. You even didn't compile once. I know it's because you're afraid of doing it on your.
It won't compile now. It's just broken totally.
Right, but I mean, you avoided it because of you don't want.
No,
You
no,
don't want
it will
compile. That's why.
it will
Okay.
compile well. It's just a matter of running tests. Running tests will disconnect me from the stream.
Okay, it was interesting. Not complete, not a complete code, but still interesting. I learned something. Thank you so much. Let's see how it will proceed next time.
Yep.
So
thanks everyone to watching this